This is part 2 of the simultaneous equation series, and in part 1 we went through a simple example using the elimination method. In this example, we'll be going through a slightly more difficult question where you require slightly more steps in getting the equations in a format that you can apply the elimination method in. Other than that, it's pretty straightforward, and the method is still the same as we used in part 1. So we have these two equations here. So we have equation 1, 4x minus 3y is equal to 15, and equation 2, 5y minus 12 is equal to 9x. If you look at equation 1, we have all the variable terms on one side and the constant on one side, whereas in equation 2 we have a mixture of variable terms on either side. And we need to get the second equation in a similar arrangement as equation 1, so that we can make the process of using the elimination method slightly simpler. So how do we get started? So we need to rearrange equation 2. So if I get that started by minus 9x on both sides and adding 12 on both sides. So this will move the constant on the right hand side and we'll move 9x onto the left hand side. So we have minus 9x plus 5y is equal to 12. Notice how I've put minus 9x as the first term. This is simply because it is in the same position as 4x in equation 1, and I just want to keep it simple and so that I can compare both equations when I need to match the coefficients. So this is still equation 2. So now we can get started with our method of elimination. So if we look at equation 1 and equation 2, how can we can decide to match either of the 9x, match either the x coefficient or the y coefficient. By looking at this, I think it will be simpler to match the y coefficients. So we have to times equation 1 by 5, and then equation 2 by 3, and this will get us 15 as the coefficient on both terms. And then we can either subtract or add to eliminate them. So equation 1 now becomes 20x minus 15y is equal to 75. So we've done 4x times 5 minus 3y times 5, which is 15, minus 15y, and then 15 times 5, which is 75. Now do the same for equation 2. We times it by 3. Minus 9x times 3 is minus 27x. 3 times plus 5 is plus 15y. 3 times 12 is 36. So now if we look at the coefficient of the y term, we have minus 15y plus 15y. So we just have to subtract add both equations to eliminate that coefficient, to eliminate that term. So we have 20x plus minus 27x, which is minus 7x. That just goes to 0. And we're left with 75 plus 36, which is 111. So now x is, if we divide by minus 7, we have minus 111 over 7. And this is our x term. So now we just need to insert this x term back into either equation 1 or 2. I'm going to go for equation 1 and then solve for y. So we have 4x minus 3y is equal to 15. 4, if we insert the x term, minus 111 over 7 minus 3y is equal to 15. Minus 4 over 7 minus 3y is equal to 15. So now we want to make y the subject of the equation so that we can essentially find what y is equal to. So here I'll add 3y to both sides and minus 15 to both sides so that we have the y term on one side and the coefficients, the constants on the other side. So then this becomes minus 444 over 7 minus 15 is equal to 3y. Now we need to divide by 3 to both sides. So we have 1 over 3 minus 444 over 7 minus 15 is equal to y. So a third of minus 444 is minus 148 over 7. A third of 15 is just minus 5. And that is equal to y. We can further simplify this by combining these two into one. So we need to convert 5 into a fraction. To do this, we need to have the same denominator. So we need to times top and bottom by 7. And then this brings us minus 148 over 7 minus 35 over 7 is equal to y. And now we just do the subtraction. So this becomes minus 183 over 7 is equal to y. So now we have the y and the x term, and to ensure that these are correct, the best method would be to substitute them in the equation 2 and see if we get the right result.